Welcome to lesson 6.5. In this video, we're going to be focusing on the second fundamental theorem of calculus. Now, in one of the last videos, we learned that the first fundamental theorem of calculus, we can take a definite integral and we can find its value using the original function and solving for the upper and lower limit. So we're going to go ahead and do that. With our example number one. We're going to use these to discover what the second fundamental theorem is. Okay, so we've got our integral from 10 to x. In this case, we have 10 as our lower limit, and we have an x. We have a variable for our upper limit. Okay, so when we plug that into our f prime of t, remember the integral, if it's the integral, the function in there would be kind of like the derivative. And when we integrate it, we're going to get the original function. So from our f prime of t, we're actually going to be getting our f of t. Only in this case, we're taking our upper limit and subtracting from it our lower limit. So our f of x minus our f of 10. When we think about these, our x going into this function is going to give us an equation. The 10 going in, however, should give us a number. All right, keep that in mind as we go to our second example problem here. In this case, you'll notice that this portion right here is the same as our example number one. That's the integral from 10 to x of f prime of t dt. Okay, the difference between 1 and 2 is that we're now taking the derivative of that definite integral. Okay, so let's take a look at this. We've got our d dx, and the value of this, we can just pull from over here, is going to be our f of x minus our f of 10. Okay, if we think about this, when we're taking the derivative of our f of x, that's going to be, our derivative is typically written as our f prime of x. Okay, we don't know exactly what the function is, but it's going to have the variable x in it, and so it becomes our f prime of x. The f of 10, however, is going to be a constant, it's going to be a number. And as you know, when we take the derivative of a number, we are going to be left with 0. So we could say that the derivative of the definite integral of f prime of t is going to be equal to f prime of x. Okay, basically plugging in the upper value or the upper limit into that function, and that's going to give us the derivative of that variable. Okay, this is known as the second fundamental theorem of calculus. So for any constant, a being the lower limit, with the variable in the upper limit, where we're taking the derivative of that definite integral, our answer is going to be that function with the variable placed in it, our f of x in this case. And this only works, of course, the condition here, if f is continuous from a to wherever x is. Okay, now you may be looking at this wondering, okay, so what happens if our variable is not in the top? What if it's in the bottom? So let's take a look at that, okay? So we've got our derivative of, in this case, our integral is going to be going from x to, we'll use 10 since we used it up above, so x to 10, and we have our f prime of t dt. Okay, so I'm using the example that was we used in 1 and 2. Only difference is I'm switching the positions of the x and the 10. So when we're looking at this, remember the first fundamental theorem of calculus. This integral, we'll take the first part of this. So we've got our d dx, and so this becomes our f of 10 minus our f of x. Okay, we're just switching places really, and so what you might be seeing at this point is that really we haven't done anything to this except that we have added a negative to it. So let's follow this through though. So if we take the derivative now, the derivative of f of 10, that is a constant. So it's going to give us 0. We're subtracting. Now the derivative of our f of x is going to be our f prime of x. And that means that our solution here is a negative f x, f prime of x in this case. Okay, that's the second fundamental theorem of calculus.